First off, something that's kind of interesting. I think all the other guests I have are people who I've like kind of met and sort of know fairly well, whereas we've not met, have we?
No.
Okay. There's, as I'm sure most of you know, like there's an awkward thing when you're an academic where under normal conditions, you're randomly meeting people over this like years and years and years at random conferences, and you never know whether you've met someone or not. So I'm really pleased that we can agree that we have not met. So lovely to meet you.
Nice to meet you as well.
Um, so I'm just going to ask you some questions. So the first one, the sort of, I'd really love to get some like context because like as someone, I've been working in this sort of historical science stuff for sort of years and years and years, and I usually kind of people don't often come out of the blue.
Yeah.
And I really love this. So I was, probably the annoying referee on your paper, and I was like, who is this person and where did this come from? And then your research profile is so interesting, right? You've got such a sort of interesting set of things that you're kind of into. And so I'd really like for you to just sort of help contextualize like this historical science, this geology stuff. Like in short, how come you do this? How did you come to it? What makes it interesting to you? Those sorts of things.
Yeah, so it's funny that you asked that question because when you were like, I haven't met you, have I? And I'm like, no. And the same thing happened when I was doing something at the PSA with Wendy Parker. And she's just like, where did you come from? And Lisa Lloyd, because I did not have any background in historical sciences or geoscience when I was in grad school. So I knew Slobodan back then. And I was working on like classical mechanics with Bob Batterman and Mark Wilson. So totally different world. But after I had a job and I was just kind of looking for a new project and I wanted to do something different. And I was looking into stuff about stable isotope analysis just because I thought there were some interesting things happening there that people hadn't talked about. I actually got in, it's just like a totally random story. So then I went down this rabbit hole about how stable isotopes were used to build the temperature record. And I just was like, I don't understand. Like it doesn't that's so weird. How does that work? And I was like, I have to know how this works. So I work at a small liberal arts college, and there's like one person here who works on sort of geochemistry. And she just happened to show up at this writing retreat that I was at the day after. And it's funny because I go to these all the time, and she's only gone to that one, and we laugh about it. And I'm like, Elizabeth, I can't figure out this problem. Can you help me? And she's like, I can't answer you, but I know this guy. He's nice. He's given some talks here. Why don't you just send him an email and ask him your question? He's a scientist. It's like, okay. So I wrote him an email, and it's always weird when you're emailing, you're like, I'm a philosopher of science and I want to know about the science behind climate science, but I'm not a climate denier. I promise it's friendly. I want to know in a friendly way. I just don't understand how you got from point A to point B. So I emailed this scientist who turned out to be Richard Alley. And I had no idea until we'd been friends for a long time that he's like very famous. He's won a Nobel Prize. He has a show on PBS, but he was super friendly. And unlike, most people in philosophy, answered his emails very quickly. And so I just kept asking him like, well, how did you do this? How did you do that? And talking to him. And then I read a bunch of stuff. And yeah, so it was totally this weird one-off project that I just wanted the answer to this question, which was, how do you get from these isotopes to a temperature record? And kind of unpacking the science of it was so fascinating to me that I thought, I've got to write about this. But then I had to figure out, I didn't know the literature or how to get involved in the conversation. So I was kind of trying to find my way as I was writing this paper, and also kind of falling in love with both historical science and geoscience. And so, yeah, I've been working on some follow-up projects to this. So I hope that even though you never saw me before, you'll see me again. But yeah, that's my story.
No, thanks. Yeah, no, I mean, I think most people who work on this, like, weirdly, you would think that most people who worked on the philosophy of paleontology or geology would be like, well, I did geology in school and then I blah, blah, blah. But actually, very few of us are like that. It's usually this kind of random story where we fell down a rabbit hole and then this happened. So yeah, and that's great. And yeah, maybe we'll hear about those future projects downstream. So maybe to the paper, because we're really going to focus on this paper and see what we can learn about it. What do you sort of take the sort of, for you, there's this question that I hate this question so much, but I'm going to ask it to you anyway. What do you take, not so much to be the central message, but to you, what's important about the paper? Like, what's the point that the paper's making that really matters to you?
Yeah, I think challenging this picture that we just get really clean laws by like doing experiments and then we know that they're stable and then every like trajectory is just the implementation of initial conditions into a set of laws. I think that this kind of challenges that. And I think I really like a picture of knowledge as being more like integrative. And I think this pushes in that direction and pushes on these big questions about how like we, about induction, really. I think like geology makes us rethink induction in really important ways. And I think this paper is like pushing towards that. But I think the big message is just that you can't separate the idea of like laws science from story science or something. These two are like deeply interwoven and like each affects the other.
Hmm.
I think that's kind of the big picture for me.
Yeah, like one of the things that really struck me when I was sort of reading the paper was, and I think partly because one of the things that's interesting about the way that this sort of sub-discipline of philosophy of historical science is sort of going along is that some proportion of people are very much coming from philosophy of biology and some proportion are coming from kind of philosophy of physics or something that's less directly coming from philosophy of biology. And I think there are some kind of different ideas about what should be pushed back against in those when you come from those different disciplines. And one of the things that I thought was really interesting was the way you were talking about laws, and at least some proportion of it really made me think about this old sort of Jack Smart paper from the sort of 1950s where Smart's like, oh, biology is the laws of physics and chemistry plus natural history descriptions. That's what biology is. And what I thought was quite interesting was that there was this way in which your sort of foil, in a sense, was someone who said something like that. And I found it really interesting to sort of be like, well, I was like, I surely don't think that, do I? And one of the things I kind of struggled with this paper, I was like, I don't think Carol thinks that, does she? And it's this really interesting case where it's like, actually, it's quite difficult to sort of show places where we don't think that. There's this interesting thing where because experimental science is sort of set up as the kind of foil, and that leads to people like Ben Jaffers going, oh, look, you just do your experiment and then you've got the knowledge and it's fine. That leads us to leave what I think you call the sort of the actualist challenge or something like that, which I think is like a really nice way of putting this. Well, hang on, how do you know this is stable? And so I think that's it's really good. Interesting.
Yeah. Well, it was funny because when I was writing this paper, I was at oh gosh, now I'm blanking. I want to say it's a GSA and that's not what it is. But what's the geophysics meeting? The big geophysics
I can
AGU.
never, yeah. Right.
AGU.
Mm-hmm.
So it was at an AGU meeting and it was funny because I'd go into all these talks on stuff about like soil science and they'd be like, and then we got these results, but the problem is it's too uniformitarian. And people kept saying this, like, we're making the uniformitarian mistake. And I was just like, that's so interesting. Because I was kind of in the process of writing this paper. And yeah, it was just very interesting to think of like, I guess the different ways, and this is part of my next project, but like kind of all the embedded ways that scientists are holding their different hypotheses. Do you know what I mean? Like, I think that it's funny because something I've been thinking about more and more is I tend to think of the sort of philosophy of biology crowd and the people around historical science as more practice-based philosophers of science, right? And so kind of going against the in principle stuff. Like we're more about the hands-on concrete. We don't do the in principle stuff. But what I keep finding, even in my own work, is this like easy way of drifting towards the in principle stuff, which I think is what you're talking about with like Carol Cleland. And it's like we want to reject that picture, but it's easy to like drift back towards it because we also want to build like clean models. And once you develop a model, it starts looking like theoretical structures. And then you start forgetting about all of the important pragmatic assumptions that scientists make that are really playing into the norms they use to evaluate their own resource or like research and how they're holding these things in tension, even when like it's kind of, you can't just see it, but just by looking at the theory or just by looking at the math, you have to like pick apart the practice and the discussion scientists are having with each other to kind of see the delicate way these different assumptions are working. I don't know, but that's also the kind of stuff that.
Yeah. So there's this huge challenge to sort of for those who aren't philosophers. There's this kind of One of the philosophers love schisms. We're all about trying to have schisms. And one of the more recent ones are philosophers who claim to be philosophers of science and practice. And the way that it's supposed to work is that there's these bad philosophers and they don't know how science works. They just think about how science must be. And then they go and like argue about the nature of scientific theories or something like this. They're interested in these things called theories. Whereas we're good philosophers, what we do is we go and look at what the science does and how it all works. The way I like, for what it's worth, I think thinking about this in terms of theory versus practice is extraordinarily unhelpful, because there's theorizing is a practice that you have, and we should try and understand that. And a more interesting way of thinking about it is whether you think you can analyze scientific products, like the representation scientists give, the hypotheses they have, blah, 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 independent of the processes that lead to them. If you think that to understand a scientific product, you need to understand the processes that scientists engage in, then you have to go and actually look at them. But if you think you can understand a product just floating on its own, like, look, here's the hypothesis, here's the evidence, I'm done, then actually you don't need to pay as much attention to the science. So that's my take on it for what it's worth.
Well, that's true, but I think it's so interesting because it ties back into like the core of this paper, right? Which is like, how much does the history matter, even in science itself? That like, can we just look at the kind of stable regularities that we can pull out right now, these products that we get, or do we have to like contextualize them inside this like really rich geohistoric history? And I mean, that's the other thing that I've loved about working in this area of science is I feel like it's so interesting from someone who really cares about like socio-historical analysis and the role that it plays in intellectual inquiry, right? I think it's like a way of seeing that fleshed out in the scientific program that I find really important.
That's nice. So I take it the thing you're getting at, which is something I've kind of said in a few places, but never very well, is something like, there's this idea that comes up quite often where people will say things like actually Carol says this quite often. She'll say, look, these bits of knowledge that they're using look like regularities. These are just gifts from other disciplines. These are things that other disciplines have kind of gone. They'll say things like, oh, carbon dating is a thing that physicists worked out that now are being applied to by paleontologists and or archaeologists. And I tend to think, no, like, as this is hopefully sort of the same sort of thing you're getting at. Look, the amount of not just contextualizing, but tweaking and like really complicated adaption and co-option of these various things for them to actually work for you as an historical scientist really requires so much work that these aren't physical theories. These aren't, they've been changed so much that we should think of them as tools of archaeologists and tools of paleontologists proper. And the idea that I should like think of these as kind of merely supporting or something like that really sort of is to miss, well, one thing, what they spend a lot of their time doing.
Yeah, no, I think that's right. And I think, yeah, it's interesting. So the other paper that I'm working on right now is about measurement and like, what does it mean to call something a proxy measurement? And there, I think you get the same thing because you can look at the proxy calibration process, and in a lot of ways, it fits perfectly into the kind of standard understanding of how you would calibrate any measuring instrument. So it looks just like a measurement. And so then it's like, well, it's not real. There's nothing really special about a proxy if you're just looking at the math or just looking at the models or just looking at the calibration procedures. But then if you read all the subtext around what they say about the calibration procedure and like, well, how do we treat these calibrations? It's completely different. What do you do with them? Completely different. How do you use them in your epistemic justification of your findings? Completely different. And so you can't it's really like, I don't know, I think you just need a richer picture of how these like inferences get played out. And I think, again, it's so easy to like go straight to, well, here's the mathematical model, here's what you do in the contemporary case, here's how the historical case is just the same way or using the same thing. And it's like, yeah, but no, because you have to build in all of these adapters and you have to reason differently. They ultimately play a different pragmatic role in your scientific inference. And I think that's really important.
Yeah, that sounds really cool. I just threw a paper in the chat in case you're not aware of it. It's a sort of recently accepted paper in the EJPS about proxy measurement and paleoclimatology.
Yes. Is it the one by Joe?
Yeah, it's Joe's one. I presume you probably know about it, but just throw it in there anyway.
Yeah. So I'm responding to that. I actually, So I think that I'm not directly responding to it, but I think he gives this classic picture of measurement, of how philosophers of science think about measurement, because proxy measurements are by scientists called indirect measurements. And I think we're philosophers of science, so we know all measurements indirect. So we're kind of like, because this has been the big thing in philosophy of science, going back to like Chang, like, it's always indirect with respect to observation. Like we don't directly observe measurements, but I actually think the indirectness that's being used in the proxy analog is a type of like causal indirectness that's very different. It has nothing to do with observational directness. So it's like, I mean, and it has to do with some of the same stuff that I talk about in this paper, but like stability. So certain relationships, like we think the relationship between the expansion of Mercury and, like heat is a very stable one, even theoretically, and we can kind of point to it by theoretical laws, right? But in a lot of the like kind of biogenic cases that you're using to develop proxies, so a very popular proxy is like the foraminifera that they create shells, and depending on the content of the water they create their shells in, they're going to have different isotopic structure. That's a biological process. And so it's not going to have the kind of stability of a thermodynamic process. And it gets really messed up when you're looking at like long time ranges. And so even if you can find kind of these correlations that look like measurement models in a calibration set that's going to be over a shorter range of time, you just don't have the license to think those are going to be reliable for your whole data set in the way that you do in standard cases of induction, in part because you've got this indirect relationship between the thing that you measure, which is the isotopic structure of the shell, and the thing you're interested in, which is temperature. And the indirectness is because that temperature got filtered through a biological organism, which is, again, a very different kind of relationship then. So anyway, so I think that's the real indirectness in proxy measurements. It doesn't have to do with observational directness.
Yeah, no, I mean, I think someone needs to make sense of. I can entirely agree with you that we should slightly move on, but I just want to say I entirely agree with you that there's something to this distinction between direct and indirect as people use it, but it cannot be observational versus not observational. That's just not how it's going to go. And I really like the story about something to do with how noisy the process is, or something like that. But I wanted to ask you about something which I found really difficult about your paper that now actually I've really come around on, which is kind of annoying. Is like, I hate it when people talk about uniformitarianism. And I hate it because I've never found it helpful. I've often found it to be such a simplistic way of thinking about historical inference. So what I mean by here is I like it when historians talk about it, like, of course, the history of it's fascinating. But when someone says, oh, uniformitarianism, thinking about that is going to tell me something about historical inference, I'm always like, ugh. Like, and so I'm initially extremely resistant to the way in which uniformitarianism plays such a central role in your paper, basically just because it's something I've never found very helpful. Happily now, I now think that there is something really important about notions of uniformity and how they play out. But what things that's interesting is, of course, you could run your argument very happily without any talk of uniformitarianism whatsoever, right? Like the claim is, hey, look, we can test historical regularities against the historical record. I don't need to say anything, use that uniformitarian machinery to say it. So I'd really like to hear about or at least maybe I'm wrong about that, but that's my hunch. So I'd be interested to hear about the role you think uniformitarianism is playing there, and also why it's playing such an interesting sort of central role.
Yeah, it's interesting. So I think this is definitely an example of what we were just talking about, like looking at the product versus looking at like the historical story of how we got there. So it's like, why is it in the paper? Well, because it was a big part of the scaffolding of my process, right? And again, I was working with these scientists who were like, well, the problem with these things is that they're too uniformitarian. And so I'm like, okay, if that's so, like, what does that mean? What do they mean when they say that, right? And so that's kind of why I was thinking that was important terminology, and I was kind of trying to work it around it and unpack it historically and be like, how has this shaped the structure of scientific inference, and how are like the received view. So it was, and I was like, one of the big papers that kind of like, I think sparked this idea for me was by Richard Alley, where he makes exactly this criticism that it's like, we've got to move, and his language is, we have to move towards actualistic methods instead of the uniformitarian ones. So I'm like, what do you mean? So I was just it's interesting because like I embraced the language of the scientific literature that I was in, and like there has been some resistance to that, I think, from people in the philosophical literature and the historical literature for these reasons, which is fair. But yeah, I don't know. But then I'm like, could I have just made my point without any appeal to that language? Well, maybe, but I think that like what I wanted to show is the way that this point and this tension is like deeply tied up in the epistemic evolution of the discipline.
Mm.
And I think to look at that, you have to look at the uniformitarian debate. And like I thought it was like a way. So something I really like about this paper is it's trying to draw together like a few different strands in a rich way.
Mm.
And they're drawn together terminologically. But I think it's more than just terminology. And I'm trying to unpack that.
Yeah, and actually, so if I can come in there, so something that I'm really liking about this and finding it interesting is that I've often taken the uniformitarian talk to be more or less apologetics, let's put it that way, where it's basically like, it's a cool thing that it's a, you know, in my view, scientists are often looking for cheap and easy ways for them to say, look, I'm legitimate, leave me alone, to scientists from other disciplines and to non-scientists. And I'd like interpreted uniformitarianism as being more or less that. It's them going, no, it's fine, here's a story about what we're doing. The same way that scientists often appeal to someone like Popper, right? Where they don't really care what Popper meant. It's just, this is a story they can tell. And what's really interesting is that you've got this very different view that I think, you know, might actually be, you know, I'm very bad at the history of science, so I'm very bad at actually being able to tell, but a really interesting different hypothesis, which is no, actually, this conception of uniformitarianism really has played a sort of substantive role in the ways in which at least some historical sciences have kind of gone. And one thing that's fascinating is I have never heard a historical scientist appeal to a unit. I've never heard them use the word uniformitarianism. Like maybe once or twice they've done it in the apologetics way, that I've maybe once or twice, but I've never heard them in the context of a scientific like conference go, whoa, we're being too uniformitarian. So that's fascinating. That's really interesting.
Yeah.
I mean,
I do wonder if it's just a way. I feel like the problem that I'm getting at, that I could have probably gotten to at a different terminological way, is a big problem right now for paleoclimatologists. And so I wonder if it's just that like that's the language, the best language they have to describe the problem, right? Of like this calibration problem. But like, but so that was, so it is, so I was then coming from that thing and trying to be like, well, why is this? What is it from that framework that is connected to this problem that they want to describe? And it kind of took me into stuff about the history of science.
Yeah, no, it's really cool. I mean, so one of the things that maybe follows on from this kind of nicely is the thing that's one of the things that I found at first just completely baffling and then actually increasingly interesting as I kind of thought about it was the thing you sort of take from Gould, which is this kind of, on the face of it, really odd distinction between laws and rates of change, right? Which is just kind of a really odd thing to sort of, you know, like it feels very just like out of nowhere to be like, oh, well, we want to distinguish between the rates of change and the law. And it might be that actually for someone who's used to thinking about like, you know, classical dynamics and stuff like that, actually those things are kind of important. But, you know, if you're coming from biology, you're like, what? Why those things? And so I'd love to hear you sort of speak to what's supposed to be sort of important for you about this sort of central distinction between holding fixed the laws and holding fixed, as it were, the sort of rates of change or the material conditions or something.
Yeah, good. So, I mean, again, this is all very like context dependent because it was like I was trying to figure out this process. And what they would tell me is like, well, look, when we're trying to unpack the temperature record, sure, you assume the laws, like, and the particular example is always like thermodynamics. They're like, we're fine with like the heat exchange. Those laws are stable, da, da, da. But then when you think about the other half of the isotopic record, which is really based on precipitation, that's really sensitive because you do know that temperature is going to affect the isotope structure, like the isotope change of precipitation. But temperature is one of many things playing into it. And we can't really presume stability over long periods of time. And so I was seeing that as this distinction between a material context and a law. And then when I went back to the uniformitarian stuff, I'm like, this is what they're missing is it's like we're just not actually very careful about what gets encoded in a law and what doesn't, and how that plays into our scientific language. And then when you get into these places where you're dealing with like very fragile regularities, I guess I would call them. And it's like what makes them fragile isn't just that they are fragile, but that in principle, we're always observing them on like long periods of time. So I
Mhm.
actually think maybe some of the laws of physics, we might think of gravity as being more fragile, or our understanding of it as being more fragile if we were always working in like a huge physical context, right? If we were always thinking about a giant part of the universe, but we're usually just thinking about stuff on Earth, or like we're usually thinking about smaller parts of the universe. And so we don't see that. But when you get into this historical science, it's so fascinating because the fragility is so much more apparent, because you're interested in context in which it's brought to the fore.
Mm.
And so you've got to think differently about your tools. Which ones of them can I trust to be stable? And which one of them should I doubt are going to be stable? And like, what are the good levers to pull for me to try to get the information that I want? And so I feel like this was a working distinction of scientists that, again, I was trying to kind of unpack. And that was how I came to bring those things apart.
Yeah, no, that's really useful. I mean, I thought that what was interesting is you sort of have this argument against this move that Gould makes, where Gould's like, hey, just like don't have the rate in the law. And I actually thought that that was what I found really interesting about that was, of course, the context for Gould saying this stuff, even though he's saying it in the '60s, so it's baby Gould, is you think about things like the sort of regularities that paleontologists care about, invert paleontologists care about, like Cope's rule, the sort of patterns of mass extinctions and things like that. It kind of seems like Cope's rule is exactly a law, individuals in a lineage get bigger as time goes by, that doesn't have a rate of change attached to it. And the kind of questions that they ask, is this a passive or a driven trend, is a question you can ask without knowing the rate of change. And so I kind of wonder that one of the things that seems to be going on, at least in that little quote from Gould, is actually this really interesting strategy that's been kind of productive for macroevolution, which I think is kind of interesting. So I think obviously it's not going to work in lots of contexts. Like it's certainly not going to work in some of the contexts you're interested in. But I actually thought there was more to say about this kind of move where Gould's like, hey, just shut up about rates of change, because there are things we can ask without caring about that.
Yeah, it's interesting. I feel like there's a lot to unpack there, because it's going to bring up questions about levels of analysis, I think. Yeah, I mean, I agree. There's a lot of like interesting places you can go with that. I didn't want to unpack that because I feel like it's a whole different, but like my immediate kind of thing there is like, yeah, just drop out the rate of change. Now we're looking at, and I think this is something that happens a lot I'm not an evolutionary biologist, but I do see these patterns when I talk to evolutionary biologists. Think like you want to look at things at like a higher macroscopic scale, which again is the question of like what level should we go to like fix our hunt for regularities or things that we can latch onto. And so yeah, there is this interesting thing, like maybe we can find a more stable pattern here if we ignore rates of
Yeah.
change.
So like a theme, like I think that I've spoken about in a few places that I think is something that should be returned to and thought more carefully about, is something I think is really fascinating, is the way how good historical scientists are at, I think I talk about it in terms of idealization, but the other way of putting it is kind of, they're really good at working out the useful scale for them given the context that they're in. And I think that's a sort of aspect of the sort of strategies they adopt that people haven't really accommodated as much as they could. So that, yeah, I think we could definitely talk about that for a long time.
Yeah.
So this conversation is going too well for me to allow people to have a break. We're just going to go straight through.
Okay.
Unless you, Megan, do you need you're right?
I'm
Okay.
fine.
So, but I do have to ask one question before I'll let everyone else go, and this is so there's this sort of joke I make when I talk about Carol Cleland's work, where I have this gif of a cat pushing another cat into a box, which is this kind of strategy where Cleland's able to go, throw at me a thing that historical scientists say, and I can say, yes, but that's not the main business, that's merely a supporting act. And you kind of note her saying this to Jaffiers. And it struck me that she could say very much exactly the same thing to you, right? She can say, yes, of course, we establish these sort of middle range theories, as I sometimes stupidly call them, these background theories that allow us to do this trace-based reasoning to identify these smoking guns by testing them against the historical record. But of course, the reason we're doing this is in order to work out about token things in the past through this isn't going to hold to your prediction point, so we'll hold that fixed, right? So a lot of these cases about, oh, look, I'm working out how to measure the precipitation good. Why am I doing that? Oh, that lets me establish what happened in token events in the past via smoking gun reasoning. So I guess it kind of struck me that the sort of move you make is open to Cleland to make the same sort of move she makes with Jaffairs.
I don't think so. I mean, I guess here's why I would push back on that. Like, I guess there's two, I'm not quite sure what you think which of my points you think she would be saying this about. Like, I think you're saying something like, well, she might still say the real aim of historical science is like token things. And then I'd be like, okay, go ask any paleoclimatologist. And they would just be like, no. Because it's like in paleoclimatology, it's very much a field that has developed and started to flourish because we care about what's happening now. I mean, it's not that people aren't just also interested in things that happened in the past, but if you look at any of the research questions, if you look at any of the funding, if you look at the way they're building their models, they're all asking questions. Like people investigating something like the Permian extinction, the research questions are specifically formed around things like what happened when you got too much CO2? How did things go haywire? And that's not just because that's what they want to know. It's because we're using it to build models to make predictions of what's going to happen now. So I just think, no, like, I mean, in terms of like, if we're talking about like a description of a field, I think that's kind of empirically.
Right. Yeah. So, but Cleland's not giving a description of a field, right? She's giving a prototypical research,
right?
A prototypical type of reasoning, right? And
yeah,
I think,
but then, yeah, I mean, I guess I'm just like, I mean, I don't know. I don't see how she could say that to me as easily because one, I do think I also have these cases where it's clearly like the very specific trajectory that you use to make the next prediction, which is like Brecker's hypothesis, because what you're getting out of the specific thing is this like different modes of operation. I also think even in the fur case, what you're really getting out of that is that's how they figured out that it was the emissions from the industrialization that was dampening the signal in the fur. So again, the aim isn't learning about a single thing. The aim is like getting the temperature record and also learning how to do that. And you're learning how to do that kind of by doing it. So, I mean, I don't know. I think the cases that I give and like the analysis I give is substantially different from the Jafar's paper. I feel like he was pushing towards like the same sort of thing that I want to push towards, but I just think it happened that the cases there you could kind of easily isolate.
yeah, it's interesting. No, I see. I mean, I guess I tend to see the points as being quite similar, but this might be to do with like, this all depends on what stage of this debate you're at, if that makes sense. And so I suppose, importantly different, right? But sort of, I see the move as being kind of similar. And maybe, so for instance, I think that, and maybe this will help my perspective come out more. So the cases that I find more telling against this token claim that Cleland's making, right? Again, anytime you talk about regularity, she says it's in service of getting token knowledge, are cases like Cope's rule, where very straightforwardly, they're interested in regularities, mass extinctions. Very straightforwardly, they're interested in the patterns of mass extinctions. When you look at those sort of macro-evolutionary events, and when you look at cycles in paleoclimatology, right, there it looks like, so the worry was something like the cases you give, and this, keep in mind, this is not in any way, this is not a real criticism, but the cases you give, because they're tied to measurement and thus sort of building up these data records, that means it's open for Cleland, however unconvincingly, to go, really what that's about is being able to do smoking gun reasoning. And to me, that gets really implausible when you're going, here's this pattern amongst a whole range of different critters, and here's how that goes. So I wonder if you can...
Yeah, that's right. Thank you for saying the question that way, because I actually have a really specific answer to this, and I didn't, but like when you bring up the smoking gun, yeah, but then what's the smoking gun? That's kind of like my point in the temperature case, because so if you can't sit, they're not interested in any, like, they're not trying to figure out if temperature influences isotope structure. That's not it. Like, it's not to find. So this is why I thought these cases were so different. Thank you. Sorry. I just like couldn't grasp the question, but I actually think that because we're not interested in like, what is the cause? We know what the cause is going into it. I mean, knowing what the cause is part of what allows us to reconstruct the measurement procedure. What we want to know is like questions about how the cause works. And so that has to be a really distinctive kind of causal knowledge than pointing a finger at what it is. Whereas in Cleland cases, all we want to do in the end is be able to point a finger at what did it. And you can't think that's the case here because we already know what did it. And what we're trying to figure out is like how and at what rate and with what kind of influences. And so it's just not a smoking gun question. Is that
Yeah,
better?
no, yeah. So she agrees that it's not a smoking gun question. She thinks that, like the Jafar's case, oh, good. What you're doing is you're working out these really important causal knowledge, which allows us to then do smoking gun reasoning.
But but it doesn't. But that's what I'm saying. Like, there's no
Right.
later smoking gun. I mean, maybe, sure, it could be a byproduct. I guess I could use a Cleveland move and say there's a byproduct that lets you do smoking gun
Yeah, I
reasoning.
mean, I guess surely the whole reason we care about that work about the furs is that it then means that I can use the furs to make inferences in the past to reconstruct the record of changes in precipitation in some area over a period of time, right? Like that's the point of knowing how to reconcile of that bit of research. The point, a point at least, is that lets me then go, oh, cool, I can trust the fur record. Funky. All right, cool. Now I can use that to do smoking gun reasoning.
But that's not smoking. I guess I don't think of that as smoking gun reasoning, because
Right.
smoking gun reasoning is what, when you want to identify a cause. So, like, what made the dinosaurs go extinct? We're looking for the cause of that. We don't know what it is. That's like a smoking gun case. In the fur case, we know kind of what the changes were. We know that temperature and changes in the climate affected them. What we want to know is more detailed structure about what that was like. And why we want to know it is because we're trying to study how the climate works so that we
Mhm.
know what's going to happen in the future. So I just don't see, again, like, you never, we like the smoking gun, we already know. It's like we already know who
Yeah.
killed
Yeah,
the
I mean, I
thing.
think I buy the. I
Yeah.
certainly. I mean, for what it's worth, it's obvious. I agree with you
Yeah.
that the idea, like, I'm. This is a very devil. I don't like playing devil's advocate, but I'm having a go at it.
Yeah.
I mean, I take it that. I mean, if I'm being very determinately Cleland, I think, I presume her answer to that first part of your response is, oh, yeah, sure. There are some increasingly fine-grained hypotheses we might have, right? Sure, I know that a great big rock killed the dinosaurs, and I might have a finer grained set of questions about exactly how it did it and what other causal factors were important. And so I get more fine grained questions, and yeah, then I'm doing smoking gun reasoning about that. So I think that her response, I mean, if she's going to stick to her guns on this, and she's very good at sticking to her guns, is going to be sort of this going more fine grained. In terms of the claim that actually it turns out the scientists care more about these more they care about how the climate works in order to project into to get some sense of what's happening now. I just think it's very hard for her to respond to that. I do suspect though, because what she means by smoking gun is actually kind of tricky in some ways, particularly in the later papers where kind of it gets more and more stretched and looks less and less like the metaphor, right? Once you start saying large and dispersed bodies of evidence can count as smoking guns, it looks much less like the determine cause by finding thing. And it's a lot more like some data which tells us about whether to prefer a hypothesis over another. Maybe I misunderstood what you're saying in the first part of your response, though.
Yeah, I don't know. I really do think, yeah. So I do think that there's a difference between, so yeah, sure, maybe you want to find out like it was a meteor that made the dinosaurs go extinct, and then you might have other questions about like how big was the meteor or something like that. Um, but there, I still feel like your big research question is like, why did the dinosaurs go extinct? And you're filling in features about that. But I don't think the research question is like, why did the tree rings sometimes get bigger and smaller? Right? Like, that's just never your question.
Good. So
So,
maybe a nice way of. Oh, sorry, I didn't mean to.
oh, no. Or
Yeah,
same thing.
yeah,
Or like,
yeah,
why are there
yeah.
changes in isotopes in the ice cores? That's not your research question. You're not looking to posit a cause in
Yeah.
any kind of detailed thing.
Yeah, so here's I think maybe a really nice way of putting it, I hope, is, one of the things that makes disagreeing with Cleveland really tricky is that she's got the sort of prototypical sort of, she's like, oh, I'm just talking about prototypical reasoning, blah, blah, blah. But the other is that she makes a claim about importance, right? And importance is really annoying. It's really hard to get a grip on importance. You can just say, yes, but what they really care about is this. And you're like, well, ah. And I think what you're saying, which I think is a really nice kind of approach, is say, no, the way we should understand importance is what is shaping and driving the research. What is the thing that makes sense of the way in which the scientists are approaching what they're doing? And in some cases, things do look like they're interested in these like token events in the past. There are circumstances where that is very clearly what's driving what a lot of the scientists are doing. But in the cases you're talking about, it just seems it's extremely implausible, right? There are things that they care about that they just wouldn't care about if they only cared about, as you say, how come the rings are more thick, right? Which is the sort of thing, like Cleland's view does seem to suggest that what they're interested in is explaining current observations, right? By positing token events in the past. And so maybe this is the sort of suggestion, is this sort of a way of putting it, is that, these are supposed to explain scientific research. And if you posit explaining a token event in the past, that just doesn't explain the research in this case.
Yeah, I think that's right. I mean, I think that, yes. So I'm a big pragmatist, and I think you should always understand scientists through the lens of well, what question are they asking, right? And I just think, so what, this was kind of what initially made me think of Cleland as the foil to the view, was it just seems so clear to me that in the paleoclimatology case, nobody wants to know what made this happen, because we know. But the stuff that we don't know is something like the details of that. And the details of that are important because we don't know what the causal process is like. So now we've kind of upended the whole view on which Cleland's story is built, because we have a different research question. And we also don't even have the kind of research tools she suggests we need, which is knowledge of the causes. And we can't get those tools from making present observations because they happen at too large of a time scale.
Yeah, no, that's great. I mean, a lot of the research I'm sort of moving into at the moment is sort of similarly interested in how do you find out about things in the past that are so different to the way that things sort of currently are.
Mm-hmm.
And so I think, yeah, this is all really useful. I guess I do actually have one more question, and this is a sort of a slightly more technical, slightly more confused question. When you're talking about methodological versus substantive accounts of stuff, which of course, we're very used to philosophers of science talking about methodological versus substantive accounts of stuff. What it took to be methodological for you seemed extremely strong, right? So there's this term of undemonstrable, although entirely necessary assumption, which sounds really strong, right? I know you're sort of taking it from Gould in some sense, but I would define methodological stuff way more casually, right?
I would too. I was
Right.
just taking it from Gould.
Okay.
That was totally heuristic, because I just wanted to say let's take his language exactly as it is. And that was a very I'm hold that fixed, but notice that he's varying more than he's being aware of. I mean, if I were just going to define methodological, I wouldn't do it that way. But that's totally because I was trying to make a point about Gould, and I had to take his definition to show that he was making a bigger move than he kind of reported.
Yeah, that's extremely reassuring because I was like, is there something weird going on with induction here?
No, I just wanted to say okay, let's give him that, but it's not going to be enough to get him this other thing. He still has to make this additional assumption, which is what I was using to separate the assumption about rates of change from laws. So it was totally just kind of doing a deductive argument on Gould. It wasn't I'm going to give the best possible definition or something like that.
Sure. No, that's really helpful. Okay, so actually, Meghan, you're happy to sort of go to the hour? Is that okay? So why don't we have a little break? Why don't we sort of rest our brains? My brain is melting. And when we come back, we'll make it more you all come in and ask questions of Meghan, and I will do my best to shut up. Though, as you've noticed, I'm very bad at it. So let's come back at 20 past. While people are coming back, Meghan, can I ask you not an annoying question, but a question, something that's really confusing me?
Yeah.
I'm going to Stockholm in a few weeks because Richard David's got a conference on theories in science, and I'm supposed to talk about theories in science, and I don't know what a theory is. Help me.
Yeah, I can't answer that question. It's you got yourself into that one.
I know.
That was your bad.
Well, I think I agreed to it because I was so confused by the invite.
Yeah.
It was just such a I mean,
that's not my response to those kinds of invites, is not to say yes, but I get invites by which I am confused, but it usually leads me to make a different inference. So yeah, I don't know. I mean, I think, I think when people think about theories, it's like maybe what you would get in a textbook. How's that?
Yeah. Things, yeah, I guess maybe one way of thinking about it is you can contrast a theory with something. So you can contrast theories with evidence. Maybe you can contrast theories with the world. Maybe that's one way of getting at it. I don't know.
Maybe are they abstract? A theory is
Yeah,
abstract.
theories are abstract. They're representations somehow.
Yeah.
It hurts. But yeah, it'll be fine. I think my plan is just to hopefully I don't think I'm talking first, so I can go and see what everyone else means and try.
Yeah.
But let's start asking. So as I always say, and as we all know, because we've been using Zoom for so many years, if you wish to come into the conversation, you could throw something up in chat. You could use your raise your hand as I'm doing right now. What a good job. Or Slobodan, are you raising your hand or just clapping? That's extremely ambiguous. Or you can even, raise your hand in your video, and I'll be looking out for that. But let's start in the big room where we have a hand raised.
Thank you. I'm really a layman in regard to chemistry and biology, but I will try to give some examples. And I'm really a layman in pronouncing uniform, but I will try to ask a question about it. So I think that defending position of uniform is really a conceptual issue, because we must first define what geological process is and what kind of parameters it includes. And for example, why some kinds of geological processes do not include atmospheric factors. And I think that for evolution of chemical evolution, we need two kinds of elements, phosphorus and nitrogen. And in regard to phosphorus, we have, I don't know, amount of CO2 in atmosphere, and because of CO2, there are lightnings, and lightnings hits the ground, and ground can be sandy, and it creates fulgurite. And in fulgurite, we can find phosphorus in the form of reduction, and that kind of phosphorus can be included in other processes. And why do we not expand the process in the geological process to atmospheric conditions? And if we want to defend uniform, we always can defend it by reducing it. If atmospheric conditions are changing, we can then say, okay, atmospheric conditions are not included in geological processes, and we still have ceteris paribus, nothing is changing in geological processes in regard to the past. And if, I don't know, something changes in amount of some elements in the minerals, we can say, okay, let's throw that out and continue to defend uniform. And my question is, how can we define geological process in the right manner?
Okay, can I try to say your question back to you and make sure that I'm like tracking with what you're asking? So I kind of take you to be asking a question about ceteris paribus and what do we choose to include in it. And so you might say, like, here's a solution to the problem, and something that will make things uniform is we just define geologic processes as things that are independent of atmospheric conditions. We ceteris paribus those. And so if it turns out that they are volatile under different ceteris paribus conditions, or under different atmospheric conditions, that doesn't mean they're not uniform. It just means that's not something that we care about with geologic processes. We just care about what they're like. We just ignore those factors, something like that. Is that your question? Okay, good. Well, then I kind of want to say this thing and say, like, you could do, what if I told you we wanted to know about chemo treatment, and I just say, like, well, chemo treatment is stable as long as you ignore certain factors about a patient's history. And so why should we ever be interested in the way those other factors include whether or not chemo works? And it's like, well, because a lot of times the decisions that we have to make are decisions about who to give chemo to and how it's going to affect them. And if there's these other factors that play into that decision about whether or not it's going to work or not, then we want to know how those factors are included in the process. So I don't think that we can think about ceteris paribus questions as being something that we can like define purely methodologically outside of the research framework we find ourselves in. And in the research framework of paleoclimatology, we're so interested in how these changing atmospheric conditions that we have are going to affect those processes. I mean, that's exactly what we want to know, because like at the heart of the question is like, how big do we need to build the walls around New York so that we don't drown in the next 100 years? And that's going to play on like a lot of specific questions about how these regularities will play out in the changing material context. And that's why I think it's like the chemo thing, because we know that chemo works on some people and it doesn't work on other people. And so we could just like ceteris paribus people from chemo and say that chemo is a process that's independent of them, but it's not going to help us be good doctors, because like what the kind of decisions that we have to make from our science is decisions about who to give chemo to. So it would be strange to ceteris paribus out some of the most like crucial pragmatic factors relevant to the questions for which our science is going to be used.
I think I might come in on this because that was really interesting. So I take it that you're right that in the case of something like paleoclimatology, where you've got something like inductive risk at play, where it really kind of, there are things we really want to know for very good reasons. But interestingly, like I've not thought about it in terms of ceteris paribus before. We might think this is kind of, when we were talking about Gould earlier, there's this kind of ceteris paribus-y strategy. We're just like, hey, I'm just gonna black box some stuff. Don't care about it. And what's interesting is that the example of, sorry, I don't know the student's name in the room, but that he kind of gave these nice examples of circumstances where it looks bad. Where if I just go, oh, geology's perfectly uniform, just let me define what geology is as I go. And I'll be like, when I find instances of non-uniformity, I'm going to ad hoc go, well, that's not a geological process, right? It's like in your paper where you say, oh, well, the substantive notion of uniformitarianism is slightly boring. If you define laws as just being exceptionless, then of course, by definition, you get uniformitarianism. But I take it that there are good versions of this ceteris paribusing going on in areas of the earth sciences all the time, where they're going, well, crap, I don't know how to deal with that one, but if I ignore it, then there's this other question I can deal with, and I'm going to zero in on that, right? And so I guess there are cases where there's more flexibility, perhaps, in terms of what we're interested in. And I wonder if, because we don't have, the world falling to pieces around us, and we need to know this information to stop it from falling down around us, in those sorts of circumstances, it seems like there are things you can ceteris paribus, and it seems like there are good cases of doing it, right?
Well, it's interesting because I think we can take your point and make it even a little bit, are actually pretty similar, I think, to some of the points that I'm making, because I think that something that scientists do all the time is ceteris paribus stuff that they actually think is important. So I think there's, but you have to do it to problem solve. But then you also have to go back and be like, but we ceteris paribus this thing. I mean, I think that's exactly what's happening in these cases, right? You're ceteris paribusing, you do ceteris paribus the stuff. But then when you start trying to like use your results to answer certain questions, you kind of have to go look back at the stuff that you ceteris paribus and say, does that matter here? And if you think that it does, I mean, this is the constant process in geoscience when we're building like big earth systems models, right? It's like, no, at first we didn't pay any attention to like soil density, and you're also evolving with like computing stuff. And it's like, you kind of think, well, here's our model, but our model ignores all of this stuff that we think is important, but it still matters. But then at the same time, we're going to go back and try to work out the stuff that we ignored, because you have to ignore it to solve the problem, but you also can't totally push it out of the way. I don't know. I mean, I think that's an ongoing problem. Yeah. But I guess I don't think like the response is to just, I think the response is to live in that tension and not to just say like, we're going to give because like the interest isn't in getting something that's uniformitarian. The interest is in getting something that gives us the answers that we want. And so I guess I thought the solution proposed could solve the conceptual problem, but at the stake, you lose the pragmatic value of science.
Sort of see, does anyone in the room want to come back on this?
Just a short comment. If we divide geological processes and atmospheric processes and all the other processes, we really are ignoring the fact that processes are dependable on one another. And I'm more about,
I don't know, a holistic view, and I think there are not many processes, but one kind, you know, and because all is dependable, and I'm for some kind of Gaia approach to answering questions in life sciences, and that's my short comment. Sorry for.
Yeah. No, I mean, I agree. I think there is a holistic approach. I also think that this is kind of what I was saying about like, if we were always thinking about huge regions of space, some physical regularities might look less stable. I'm definitely sympathetic that like you could push this in the other direction and say like, well, maybe other parts of science aren't as uniformitarian as we think they are or something like that. But it's just that the things that we've ceteris paribus don't tend to matter as much. Where we're in this really interesting situation with earth science where it's like, we kind of need to know it all and how it all works together. And we don't have one theory, Adrian, to use your favorite word, to fit it all into. So we've got to look at these kind of interplays. But I think that's what makes geoscience such an interesting place to be as a philosopher of science, because you get to think about these questions.
Great. Slobodan?
Okay, so one thing that has been really annoying me since the beginning of this part of the course is this Cleland's distinction between or her view that historical scientists borrow these regularities and laws, let's call them laws, and then they apply them to these tokens and so on. I mean, the first impression is, well, that kind of sounds right, but then one thing that I have a problem with is that I cannot really get rid of this uncharitable reading that I have of it, so that, you know, it somehow follows that historical scientists are not really, I mean, methodologically and epistemically, they're sort of a lesser kind of, you know, knowledge gatherers, let's say, that deal only with particular phenomena and cases, whereas these people who establish these laws, which are then applied, are the real deal, right? So historical scientists are never going to get any Nobel Prizes. So, you know, they have to deal with that. I mean, obviously she didn't think that, but it seems to me one thing to kind of test her view. So it's not only historical science, also, for example, astrobiology. Astrobiologists would immediately fit there, right? So biology, evolutionary theory is the sort of the founding theory. And then everything that astrobiologists will say, well, we have these very general evolutionary laws and in I don't know, population evolution and various statistical regularities and so on. So whatever they find, they have to kind of look up to sort of that sort of a regularity. But the problem is that the laws really and these theories kind of a background, they're really background theories, it seems to me. They offer a myriad of models and possibilities. And figuring out which possibility is actually correct in an actual case is neither trivial nor it's actually something that concerns only that particular case, I think. And it's figuring out the background laws is only, I wouldn't say even half a job done, but maybe 1/10 of a job done. And that's actually when you test this distinction in other sciences, such as physics, for example, it really sort of comes out very weird, because even in fundamental physics, you're going to have these foundational laws, people, and then you're going to have these other physicists who, according to Cleland's distinction, are doing something that's epistemically of a lesser sort, right? So really two foundational theories, if you look at like sort of hardcore physics, fundamental physics, particle physics, right? You have two foundational theories, quantum field theory, quantum electrodynamics, and they give you a host of possible domains or models. And then you have to devise models for your own world, how actually atoms are put together, how subatomic structures are put together, and you're going to have like several alternatives. They're all going to be underdetermined. You're going to do experiments, but that's not even the end of the story, because then you have phenomenological theories, which are going to tell you what sort of detection items you will get based on your model, which is loosely based on the background theories. So it seems to me that's actually applicable to historical sciences. Similar kind of distinction is applicable to historical sciences as well. The fact that we have regularities, background regularities from which scientists, historical sciences start with, it doesn't really give you even half of the answer about the phenomena that you care about. And that sort of goes back to Adrian's maybe a concern, what is a theory? Well, in some sense, there are different kinds of theories based on the sort of level of generality, but typically you do not infer models from background theories, nor you infer phenomenological theories from your models. It's a much more complicated, substantial process, actually. So anyways, that was my uncharitable reading of Cleland's account. It was more of a comment on that distinction.
Yeah. So actually what you were saying, like I have a lot of things to say, but I'm hesitant to say any of them because it's going to sound like I'm jumping the shark and going in a totally different direction. So Adrian, do you have, is that okay if I go a little crazy or?
Yeah, no, I mean, go buck wild. Go for
Okay.
it.
So here are just random things that I was thinking when you were talking. This is kind of, so Silvana and I were at Pittsburgh at the same time and we would ride the bus together. That's that's my memories of you and just having weird conversations. And this is going to go that direction. So things that were in my mind. One, so part of the Cleland thing that I think is going on there is this more interesting phenomenon that happens all the time in philosophy of science, which is we're all screw the DN model. And then it's in everything. Like the DN model always comes back. Every single time, so many papers by people I'm sure I do it, but it's because people who are F the DN model. And then there it is all the time. It just creeps in. Something about that model is so embedded in how we think. And I see it there. There's this other thing that I think about a lot because, and I think about it, so as Adrian was saying, I have really weird interests and I also do stuff in philosophy, religion, and theology. And there, it's just dominated completely by this weird picture of how philosophy works that I think of as very steeped in a pre-positivist analytic perspective of modality or something. So I mean, really, it's just this idea that, yeah, so Craig Callender has an interesting paper on this, on the analytic empirical divide, but it goes back to this idea about models where people think oh, once you get the theory, it's you have this big theory and it gives you all the possibilities. And then scientists are just like in the business of telling us which world we're in, right? Like which possible world are we in? We just, really we can figure out the whole structure and everything independent of the science. We get this like big possible world structure. And then scientists go out and say, and like, we're in this world. And I think that's kind of the same thing as your uncharitable reading of Cleland, which I'm not saying it's uncharitable. You called it uncharitable. It might be right. But like the picture of like, well, theoretical scientists kind of like figure out all the possible trajectories there could be. And then historical scientists just go say, and it's that one, right? But really the process of knowledge building and the theory, like the role of empiricism, the role of experiment, how we get to knowledge is so much more complicated. And I think there's this huge, big question here in the background. And it's a question that drives so much of my research. And it's the question of what is the interplay between like the individual story and then like the communal language in like the shared picture, right? And so I think that's kind of part of what's happening here with the historical theoretical interplay is it's this question of like the single story and then the knowledge network. And how does a single story play into a knowledge network, which I think that reverberates throughout lots of questions in philosophy. But I think this is a really interesting way to approach it. And it's also what you were saying. It's funny because it makes me think, just to connect this back to philosophy of religion, I was just reading this paper that really irritated me the other day on, this is recorded. Edit that out. I was reading a paper the other day about this question in philosophy of religion of how do narratives in religion connect with like religious theory. And the account given was like, oh, it's just like Van Frossen's theory where we have philosophical theology, which gives us all of, it's like generates lots of models. And then narratives just kind of work out the different possibilities of how things might be in a different model. And I was like, that can't work pragmatically because what you get is the narratives. And you couldn't epistemically move in the other direction, right? You couldn't just move from a possible world to a theory. But like all of our evidence would come in the form of these like concrete possibilities. And so this doesn't actually answer the pragmatic question of how these two interact, whatever. That's me jumping the shark and saying all the things that I was thinking when you're talking.
I mean, I wanted to add a little, like, I really like that there's a sort of, occasionally we're doing these little reflections on sort of the things that structure the philosophy of science and why philosophy of science is weird in the way that it is. And I wonder if in addition to your point about the DN model, for those who aren't philosophers, the DN model is roughly this account that was a very popular account of, we tell ourselves it was a very popular account of explanation. Philosophers, anytime a philosopher makes a claim about history, it's false and they're lying. But philosophers in the 1970s and 80s liked to say that back in the bad old days of the 1930s and 40s and 50s, philosophers thought that scientific explanation took the form of a deductive nomological model, which is basically deductive. So you have logically valid, right? So you go from the truth of the premises guaranteed, the truth of the conclusion, where the premises are, I'm being a teacher here, Megan, sorry, where the premises are basically states of the world and laws. They are the explanans, if you want, and then the conclusion, the explanandum, is the thing you're trying to explain. And so when I explain something, what I do is I give you a set of initial conditions and I give you a set of laws, and those things in combination guarantee the truth of the explanation. And so you're thinking about explanation as a kind of linguistic act that follows these kind of logical rules. And Megan's point was that, well, I think there's 2 points there. One is there's this weird tendency for philosophers, there's a sort of ritualistic kind of going, the DN model is bad, which is kind of weird because if we all know that the DN model is bad, why do we keep needing to say that? But also it keeps coming back in again. And I take it part of the coming back in again is because philosophers, this is going back to what Megan was saying at the very beginning of this discussion, we like systematizing things. Like what it is to give a philosophical explanation is to abstract in various ways, is to, this is part of how we get this sort of normative grip. And the DN model, that's a great way of abstracting certain types of evidential reasoning, maybe as part of the story as to why it keeps kind of coming back. It's actually a really useful tool. It just really misses a lot of the rich dynamics that Megan was sort of pointing to. You look like you want to come in. Maybe I've got something wrong, or
No, I was just thinking the other thing that is like percolating in my head, where that I think this is related to part of the DN stuff and this theoretical whatever divide is I often think that the scientific picture of the world is still this very classical kind of like Laplace's demon picture, right? Where it's just like, that is what the world is like. There are laws, there are initial conditions, put those together and you've got the world.
Yeah.
And no matter how many times people say, well, it's not quite like that, I think that's just our default reasoning model so often for thinking about the scientific view and even philosophers of science, you know.
Right.
And then I think, and then what people will do is they're like, they keep that model, even if they move to a more quantum approach, it's like you keep that model and it's just like, but the laws are probabilistic, which is actually false in quantum mechanics. But then that's the picture that people get, you know. It's still, it's like you've got the initial conditions, but now it's just like you don't have as reliable laws. But that's how we think about laws.
Which ironically, of course, was like Hempel's original model, right?
Right.
Like there's no move, hasn't moved on at all. So maybe an addition I wanted to make to this was there's another kind of back and forth, which is a bit later, that I think plays a sort of interesting kind of role here, which is the disunified view of science here, which really is the sort of notion of pluralism. And I want to sort of bring this up because one thing you said earlier on that I think might matter here is you sort of appeal to this notion of you thinking that sort of integration is important. And it sort of struck me that this is something that I've been, that has exercised me for a long time, is you sort of look at this debate where originally philosophers are like, science is unified. And then they got increasingly weird about what that in fact meant. And then they sort of seem to go wildly in the other direction, where there's this idea, no, science is disunified, by which I mean, we can think about all of these scientific explanatory projects as autonomous explanatory projects. And so you end up with psychology being autonomous of cognitive neuroscience, or, you know, all of these different sciences somehow being independent in some kind of, in principle sense. And that always struck me, especially when you look at I think the historical sciences are really useful for showing how sort of mistaken that dichotomy is, because what you get is not, as you say, the theory gives me this sort of possibility space, and then I have some data that lets me, you know, say this world. What you get is this incredibly complicated set of like weird partial models and stuff that get kind of thrown at the data, and the data gets thrown at those models, and they end up sort of cobbling together some kind of sort of picture. And it's fundamentally integrative. It's not, here are these sort of disunified in the sense of being autonomous from each other kinds of projects. You can articulate them as being disunified once you sit in your philosopher's chair and say, well, this is the why question they're asking. But when you look at the practice, these things are so knitted together. So I guess I wanted to give that rant and then see whether you agreed or you'd put it differently or what.
No, I do agree. But it's funny because in some ways I think the medium is the message. So I think too, the whole thing about it was all about science is unified, and then it was like science is disunified. I feel like that has to be understood in a socio-historic context, because I think the disunity of science was supposed, in a lot of ways, it was a response to reductionism. And so I think like saying that things were autonomous, it was just all about avoiding this philosophical thesis of reductionism. But autonomous, like if just taking, again, if you take it out of that context, saying a science is autonomous is a much stronger claim. That I don't know that I would be committed to that. Because like sciences are integrated and work together, but the way they do it is like messy and often one-off. And so yeah, it's tricky. So anyway, I think again, these like, yeah, it's like, do you think science is unified or disunified? It's just like, whoa, you've got to really unpack that in the historical tradition of like what happened in the history of philosophy of science. But so again, this is why I love geoscience. This is why I love paleoclimatology, because it's one, a question that really, really matters to all of us is like, what's going to go down and what can we do to like try to make it better or mitigate, you know, some of the damage or survive. Really, it's a question of survival. I think like, how do we continue to survive on this earth as it changes? And the kind of stuff that we need to know to answer that question just forces us to integrate disparate theories. And it also forces us to engage in what you would call, Adrian, like scientific creativity, because there's not always, we don't have a way of doing it, right? It's just like this really important problem that we need to solve as quickly as possible using any resource we can get our hands on. And so like what you see is like so much like scientific creativity, development of new scientific strategies, and ways like sort of on the ground ways that we end up integrating different aspects of science that aren't, you know what I mean? And then you see how they all play together, and then you integrate one and you've got to go back and recorrect for how you integrate it. And this all comes out in models. So I think it's a super interesting, like from challenge to the history of philosophy of science, and like a new epistemic background to approach a lot of like our old traditional philosophical questions, which were of course entrenched in the framework of the time that had to do with, I think, you know, all of the stuff about the DN model and this classical picture of physics. And then like, maybe there's also some probability and whatever. Now we're just dealing with like a whole different scientific framework, and we need a whole new picture, but I think we got to build it from the bottom up.
Yeah. And also we need to, I mean, one of the other tricky things is creating space within the philosophy of science to be able to talk sensibly about this, because things are so different from a lot of the, well, the sort of things you might want to say are so different from the kinds of things, the sort of framings that philosophers of science often have, that it's actually difficult to work out strategies to actually be able to sort of publish, right?
Yeah,
And so,
yeah.
it's a really interesting sort of area just from a pure Machiavellian academic strategy context. I do want to check, so we're going to finish up soon, but I just want to check whether anyone else has any sort of things they want to sort of raise at this point, because hopefully it's kind of obvious that Meghan and Slobodan could go back and forth for all time, and that would be very fascinating, but I want to see if anyone else wants to come in. Yeah, Francesca.
Yeah, sure. So I found this last point you said very interesting about integrating, and also integrating different approaches. Because what I found interesting about the paper in the end is that you liken this kind of taking the historical record to doing experiments kind of methodologically. That's right at the end. I think it's only one sentence, but I thought that was interesting also in terms of this discussion of do the historical sciences do something different than other sciences, and this whole Cleland debate. Because initially I was thinking that, I mean, really, if you're interested in, let's call it non-historical regularities, or regularities you're going to use for something else, and then you use the historical record, are you actually still doing historical science then? And or are you still interested in maybe how we, because you're not interested in how we generate knowledge about the past anymore, but to something else. I hope that made sense. So I guess, I mean, this is not really a question, but reflecting on what you said now, I think an interesting point there is that maybe it doesn't even matter so much. And if we bring in the historical record to answer questions about the here and now, do we say something about what historical scientists do or don't do? I mean, maybe it can be both, and it doesn't even matter so much. I mean, this is kind of expanding on the thought I had on Tuesday. I hope what I said made sense. Anyway.
Yeah, no, it does. I also kind of think like this fits really nicely with what Adrian was saying about like the need to be creative in how you're going to say stuff in the literature. Because it's like, where was I at when I was writing this paper? I'm like, well, whoa, this is a super cool thing that scientists do, and I want to talk about it. How do I, like, where do I talk about it? And it's just no one was talking about those specific procedures. And the conversation that it best linked up with, I thought, was this Cleland stuff, because she's saying, well, here's what historical scientists do. And I was like, not these guys. So it was like, you know, but it's not like I have an independent motivation that I want to say historical science and science are distinct. I think like, but at the same time, I do think there's something deep and important in noticing like ideographic strategies and nomothetic strategies and how they're different. And I think that like conceptually parsing them is helpful for us building a model of how they work together, right? So like on the one hand, I'm not here to say, I don't want to carve out and say like, this is what historical science is, and here's how it's different. That's not kind of the end goal of my project. I kind of want to say like let's look at the interesting ways that science works. And to do that, you know, it's helpful to like parse out kind of historical approaches and the problems that come up there. And like, so it's funny because like, I actually think of a lot of the things that I talk about as narrative science, or I think of ideographic science as narrative science, but my stuff, I don't want to call it that because so far, most stuff about narrative science is always about explanation. And I think the temperature record is, again, this really interesting thing because it's a narrative, but it's not it's not a narrative explanation. But I think it's a narrative insofar it's about telling a like special story. So again, my big picture interests are just in like knowledge. How does it work? How does science work? What are people doing? And the like kind of separation of historical and theoretical science, I think of as scaffolding and as like a means to an end and as like a way to enrich in the model, but not as like wanting to draw a hard and fast line that could never be moved. Does that help?
Yeah, it might be that sort of a general lesson here is when you're reading philosophy, I think whether or not you're a philosopher, you should always be kind of selfish in terms of what your interests are and also trying to tend to how they're situating themselves. And one thing that's very striking about the historical science literature of the last 20 years is that it's really been sort of motivated by sort of two things. So a lot of my work is very similar to Meghan's, but I don't care about the relationship between historical science and experimental science. Like, as you've heard me say several times in the last couple of weeks, like, I just think that those distinctions are so coarse that the idea that they would tell us anything is kind of silly, right? They're really, really coarse-grained distinctions. But it's really useful to be able to have these things that then give me a space to say stuff, right? And Derek Turner's work has been like that as well, right? Like, I don't care about realism or anti-realism about the past, if that's the way he frames it, but it gives me something to push back against. And it's really interesting to sort of see the way in which these things kind of have this dialectical structure, kind of in virtue of the way that publishing works, I guess. Mm-hmm. That was a really weird thing to sort of start ending on. So before we thank Meghan, I just want to like make a few sort of notes. So we're going to take a wild handbrake turn next week and look at a chapter from Caitlin Wiley's new book. So we're going to be thinking about a much more sort of anthropological sort of think about the way that data is produced in paleontology in this case. And then we'll talk to Caitlin on Thursday. It's going to be super fun. Hopefully you all agree with me that like I could kind of listen to Meghan talk about this stuff for like forever. And I feel really honored to have got to listen to it for 90 minutes. So join me in thanking Meghan for, you know, being so good with her time and just writing a great paper and talking about it wonderfully.
Thank you. Well, thank you for inviting me to be part of this course. It's really great. And it's great to get to talk about this with you guys. Yeah. Thank you so much.
Awesome. All right. I'll see you all next week. And Meghan will be in touch, of course.
Great. Bye.